Hey everyone, welcome to this part two or session two of the Hackster Live contest. We have a really interesting build along for you, and at the end, we'll open it up for some questions. I'm Rajan, I'm a tech evangelist with Qualcomm Technologies, and today I have Ramya with me.
Hi everyone, I am a tech evangelist with Qualcomm as well. So very excited to be on this Discord. Looking forward to share some exciting workings on the UnoQ itself. So, yeah,
Awesome.
handing
So
over to Rajan.
we have a very interesting session for you. We'll go through a quick recap on the Hackster contest, where we are, some timelines. We'll do a hands-on with Ramya. She'll walk us through keyword spotting use case that you can use on the Arduino Uno Q, and at the end we'll open it up for some Q&A. So really excited for this. Let's jump right in. So anybody who has been following, we have this awesome Hackster contest running for the Arduino Uno Q that is based on one of Qualcomm's SoCs. And as part of this contest, we are seeding 300 Uno Q boards up for grabs. So phase one of this is you apply for hardware, we evaluate the projects that you guys are building, and we are going to seed 300 boards for this contest. So quick update on that. So the 300 boards are in Hackster warehouse as of yesterday. They already have them. And in terms of timelines, I think April 5th, which is this Sunday, is the deadline for applying for hardware. So if you haven't already done so, please go ahead and apply for hardware. We have the judges standing by. We are already starting to evaluate the projects that have been submitted. From a timeline perspective, I think we will start shipping out the boards first week of May. So I'll touch base on the timeline a little bit later. But here's the link for the contest. If you haven't already done so, go ahead, register, and start building your projects on this awesome little board. Why build your projects on this board, right? Why? What is in it for you? One, yeah, you get to invent the future for sure. You get to work on cool projects, but there's also some prizes associated with it, right? So the first prize is $5,000 value. We have a full expense paid trip to Maker Faire Rome down the year. We have also the Snapdragon Samsung XR device, which will be a giveaway as part of this, a bunch of swag. And then we have various categories as well: best in robotics, best in industrial IoT, best in gaming, home automation, social impact, and so on. So whatever awesome project you are thinking on, you can pick and choose which track you want to participate, or you can participate in multiple tracks. So go ahead, look at these. These are awesome prizes, and on top of it, every category, the top prize and individual categories will all get uh, Arduino Ventuno Q board. So the latest Ventuno Q board, which is much more capable than the Uno Q board, is also part of the final awards that we are giving away. So if you are looking forward to building on top of these platforms, this is the perfect opportunity for you to get your hands on really nice boards. So in terms of timeline, like I said, application for hardware closes April 5th, right? So we already have, I think last I checked today morning, 800 plus applications for hardware, but there are 3,000 plus contestants already working on this, right? So, but out of those 3,000, 800 of them have applied for hardware. So if you're still waiting to apply for hardware, I would highly encourage go ahead and put your applications in. Uh, you never know, you will end up with one of these 300 Uno Q boards. And then once the hardware application closes, we'll go through judging. And May 1st is when we plan to tentatively announce the 300 winners for the boards, for the hardware boards. Uh, and we'll start distributing shortly after that. But that shouldn't stop the rest of the contestants, right? So these are pretty accessible boards. These are like $59. You can get them globally. So the contest actually goes on till August 30, right? So between May and August, you still have a lot of time to start building your projects, get those boards, get a bunch of sensors, peripherals that you want to integrate with, and just start hacking. And then winners will be announced later during the year. So with that, what are the boards that we are seeking in the contest? Right, we talked a little bit about this in part one of the session. So if you want to do a deep dive on that, go check that session out on YouTube. We had Ash in that session also talking about some computer vision use cases, and we went through an overview of the Arduino board. Right, so the Arduino Uno Q is this little single board computer that has both an MPU and an MCU. If you're familiar with Arduinos, the Uno series had this STM32 microcontroller, and you could program that microcontroller using Arduino IDE. You can write your own sketches, and it was really intuitive and quick to get started. And you would be able to do really awesome sensor integration and get in a bunch of data and whatnot. Now, on top of that, you also have the Qualcomm Dragonwing QRB 2210, which is an MPU which is running a full Debian OS. So now you can run a little bit more complex use cases like computer vision, like keyword spotting, to enhance those sensor use cases that you have. So that's the board that we will be seeding. Just a quick call out on some peripherals that are available on the board. It has the Uno header, so you can definitely integrate all the Uno shields that you had in the past. They all go to the same STM32, right? So you will have the same kind of ecosystem from a microcontroller perspective. You can use the same shields on there. But it also has a bunch of high-speed connectors, which are compatible with the new Arduino carriers that the MPU can start making use of. Right, so you have the best of both worlds. You can have a full Debian system, run your Debian, run your Python code, and then you can have your microcontroller, run sketches, and so on. So what brings all of that together, right? So you will be working with a couple of different software stacks. Arduino App Lab is one of them. So App Lab integrates the best of both worlds. App Lab is uh, the evolution of Arduino IDE. That's how I like to think of it. It will let you run the Python code on the MPU, but it will also compile your sketches and flash them on the MCU. So within App Lab, you can do both. You can run your Python scripts on the Debian, and you can compile your sketches, and you can flash them on the MCU. So App Lab, again, that'll be one of the software tools that will be easier for you to use on the Uno Q boards. This is the link to downloading App Lab. If somebody doesn't have the link, here is a quick link to download App Lab. You can always just go to arduino.cc and find it. It's pretty intuitive. The other piece of software is Edge Impulse, and Ramya will dive more into Edge Impulse. But Edge Impulse, just to give you a preview, is a platform that helps you collect your data, train your model, and run them on any hardware. Whether it's computer vision data, whether it's time series data, audio data, you name it, you have the option of collecting data, training it, deploying it, all within that one platform. And App Lab is integrated with Edge Impulse in the backend, right? So we'll see a little bit of how that works, and Ramya will take us into a deep dive of a keyword spotting use case. So without further, I'll hop back in. We'll monitor the channels in the background. If somebody has any questions, we'll pick them up. But I would like to hand it off to Ramya to take us through the hands-on portion of it.
Thank you, Rajan. That was really a descriptive story about the queues, what all goes into the queues. So, great job on that. Now, very excited to move on to the next part, which is the hands-on part, where I will be covering a keyword spotting example. Um, so, let me switch to my Arduino GUI. I need a moment here to bring it up.
Yes, we can
That's
see.
my Arduino booting up. Mhm.
Yeah.
Yep. So just a note before I continue with the example. The Arduino itself can be used in two separate modes. One is the host mode where you would be directly connecting a USB-C type cable to the Arduino and using the Arduino App Lab on the host. Uh, and you could also use ADB commands to access the Arduino shell. But there's another mode which is called as the SBC mode, which is the single board computer mode. This is where you would be connecting a USB-C hub to the Arduino UnoQ, and then you could connect peripherals like keyboard, mouse, and a monitor to make the UnoQ its own computer, standalone computer, right? So I'm using this standalone computer mode. Uh, but then instead of using a monitor, I've just used a HDMI to USB converter. So I can show the GUI of Arduino in this demo. So that's my Arduino booted up, and I am logging it into it. Uh, Also, the Arduino UnoQ comes with AppLab installed on it. So you can either use the AppLab on the host PC, or you could use the AppLab directly from the UnoQ device. So right out of the box, this is how the UnoQ looks. It is loaded with a lot of sample apps that fall into different buckets. Could be AI apps which classify images, which segment the images, or it could be examples that work with the onboard LED matrix or the onboard LEDs itself. And for our demo today, I will be using the Hey Arduino example, which is the keyword spotting example. So uh, this example is using an AI model which has been trained to detect the word Arduino. So this is how the example looks like. So there's a README block for every example, which basically mentions what are the different code pieces used, what are the different bricks used. So brick is another new concept that came to the Arduino UnoQ. It's nothing but a reusable block of code. Uh, it's readily available. You could use it when you're developing your own app, so it reduces the amount of time you spend on coding. So the README consists of all the bricks used, what are the different software components that are used for running this example, and how you launch the example, how the end-to-end, how the app works, and also what is happening on the MPU side of things, where there's the actual Python code running, and what is happening on the MCU side of things, where the actual sketch, the C++ code is running. So that is the README, and we have few other components uh, that are significant in the whole app. That's app.yaml file. This is where we will be inserting the different custom models once we have them, when we are like building our own apps. We have the Python code itself, the main.py file. This is where you would be invoking the different APIs. You would be printing some text on screen. And we also have these sketches, the sketch.ino file, which again calls the router bridge. This is a mechanism used in UnoQ board to communicate, to establish communication between the MPU and the MCU. There's also the bricks. So keyword spotting is the brick that's used in this example. So it also, so there's this overview about the brick, what are its features, how the code can be used. And there's a whole documentation on the API itself. And then we have this section called AI models. This specifies which model from the edge impulse we are using in this particular example. So going back and running the example itself, so it is as simple as just hitting the run button. So now it's building the app, and then once it's ready, I'm going to run it on the device. So building of the app is done. So now it would be the test time, which is I'm going to speak the keyword "Hey Arduino" into the mic, and then you can see the onboard LED matrix glow up.
Yeah, give it a second. Let's put uh, you back on the stage. Let's stop sharing your screen for a bit. Yeah, there you go. You can go ahead now.
Oh, all good.
Yeah, all good.
Hey Arduino.
Can you bring the
Hey
Arduino
Arduino.
more up? Can you bring the Arduino more up a little bit? Yeah, there you go.
Hey Arduino. Hey Arduino. Hey Arduino.
There you go.
Yeah, you see how it's the LED matrix is lighting up when uh, the mic
Sorry,
is
can
detecting.
you do that one more time and hold it a bit up? The camera didn't capture it fully. Sorry.
Yes. Let me know when it's in
Yeah,
the perfect.
yeah, that's
Good.
good.
Hey Arduino. Hey Arduino. Hey Arduino. What's up? Give me a moment there. Maybe it's a loose
It,
connection of the mic somewhere.
it works pretty consistently. I don't know. It's Murphy's law. Whenever you have to give a demo, that's what happens.
Yeah.
Oh, there you go. It did. Yeah,
Hey Arduino. Hey Arduino.
there you go.
Okay. Yeah. Like it's slow. Okay.
Yeah,
Did we get a good visual of that?
we did. Yeah,
Yeah.
there you
Yeah.
go.
Okay. So moving on to the next part.
Yeah, we can share
So
the screen back up. Yeah,
yeah.
and it's coming up in three, two, one.
So that was the example project that comes as a part of the app lab. But then if you would like to train your own keyword spotting model with your custom keywords, we use the Edge Impulse platform. So like Rajan said, Edge Impulse is this free platform where developers can build their own end-to-end AI ML pipeline, right from collecting the data to deploying it on the device. Is my screen visible at all?
It's coming up. It's not up yet.
Okay, I have the Edge Impulse website open.
Yes, it's up now. Yeah.
Okay, sure. So I just went to edgeimpulse.com and this is my profile. Like uh, once you go to Edge Impulse, sorry, I would like to go a step back. So this is how I would like to show the login part as well. So once you have an account created, you just log in here, and then this is how the dashboard looks like on the very first login. So I have a project created here for the demo purpose, but when it's the first time you're logging in, you have an option to create your own project. So this is how the create new project looks like. Coming back to our project here. So Yeah, this is the dashboard. This is where you get started with collecting your own data and then training a neural network in the Edge Impulse platform and then deploying it. On the left, you see these different stages of the model pipeline. You have data acquisition where the actual data collection happens. You have creating an impulse, which is ideally building that whole ML pipeline by putting together the processing blocks. I'll walk you through those steps, and then we have the deployment itself. That's the final step. But going back to the dashboard. So I've already done a part of this project just to save some time, but I'm going to show how the different parts work, like collecting the data. I'm going to collect data of lower sample size here, but this is how it's going to look like. So you could collect data by using your phone. You could scan this QR code, and Edge Impulse website opens up on the phone, and you could use the phone to record the audio samples, or you could use the mic on your computer, or if you have a device or a development board connected to your computer, you could use that too. But for this example, I would like to use my phone because I have issues with the mic on my computer. So just I'm just scanning my QR code, and then whenever the phone is collected, it shows up on the screen, and then I'm collecting audio here. So it asks for a permission to access the microphone, and then probably I could show the same thing here. Give me 1 second. I'm just repeating the same step again. Okay. So I'm labeling my data as in 3 different buckets for this project. It's going to be Qualcomm, Dragonwing, and Snapdragon. I've already collected a couple of samples in my training data, but for the demo purpose, I'm going to be collecting the keyword Qualcomm for about 5 seconds now. And we should then be able to see the samples being collected here. So I'm going to enter a label, set the time length as 5 seconds, and then start recording. Qualcomm, Qualcomm, Qualcomm. So you could see I have new sample here. So the next step after collecting the samples would be splitting the samples. And this is how we do it. So these are the sample windows. So there's an auto selector running in the Edge Impulse which detects that word in the entire recording. So you could manually adjust the size to your sample, and then hit on split. So that's splitting the data. And then we move on to the next part, which is creating an impulse. So creating an impulse is nothing but building your entire pipeline. So for the data we collected earlier, these are the window sizes and the strides that are populated by default. So I'm going to be using the same that are there. And Sorry. Okay. This is how you create a new impulse. Yeah. So we would be adding our processing blocks, learning blocks, etc. A processing block is ideally the signal processing block which better suits our data set. So in this case, since it's a voice-based data, it's going to be the audio MFE block. That's going to be the processing unit. And I'll be adding that here. And then we are going to select a neural network in this pipeline. And there's a neural network that specifically suits the keyword spotting app. So I'm going to add it to my pipeline here. And then I'm going to be saving the impulse. So, and then the next couple of steps are basically working on the data itself. So the final data that we feed to the neural network is having distinctive features, and when we run the final inference, the keywords can be detected properly. So in this step, we generate the features for our data set. So this has spectrogram of the different words that I collected using the um, data acquisition tab on the left. So we do generate features here. So this step takes a while, but what it's going to give us is how distinctive these three different keywords are, and how well they can be detected when we run the final inference. Waiting for the feature explorer to load.
So you will see in a minute how this is useful to visualize it, right? So if you're having multiple keywords in your application, you really want to see something that you don't see a lot of overlap, right? So if you have three different keywords, you want to see those keywords in their own bundle. You don't want to see a lot of overlap.
Yeah. Yeah, you can visualize this as, for example, if there are keywords which rhyme a lot, like file, tile, etc., maybe the clusters would have, maybe the dots would have been slightly overlapped on each other. But with the keywords that we selected right now, they are pretty distinctive. So that's a good data set. That's an indication of a good data set. So coming back to the next step, it's the transfer learning. So this is the step where we feed that data we got in the MFE step to the neural network. Here it is the MobileNet V2, and then we train the model with that data set. So I'm going to be skipping this part because this takes a lot of time for the demo, but I've already trained the model for another impulse. So I'm going to be switching back to that other impulse, and this is how uh, the output looks after we do the model training. So it gives you the accuracy for the three different keywords, and few other stats on how distinctive the data is, what is the inferencing time and everything. So Once we have the model ready, we have the deployment phase. So we come to the deployment, and then here we have an option to select between a lot of embedded devices. So since we're going to use the Arduino UnoQ, we just search for the UnoQ here. And then we want the quantized model for the keyword spotting app. So we select the quantized model, and then we hit the build option. So what this step does is it creates a final EIM binary file, which we can take and put it on the Arduino device in the keyword spotting example. So now the example uses this new model to detect the keywords. So there's also an option in Edge Impulse to view the simulation results before deploying it on the device itself. So this is how it will look like. I'm going to give it a minute to build the model. So the model is built, and then the EIM file would get downloaded to your host PC. So the simulation results can be viewed here. You could just launch it in the website. Uh, as I said, I have an issue with my mic, so this is probably not going to work. But this is how the simulation looks like. Dragon wing, dragon wing, dragon wing. Okay, my mic is working right now. You can see the scores going up whenever I say the word dragon wing. Dragon wing. Yep. Qualcomm. Qualcomm. So the confidence scores are anywhere, they range anywhere from 0 to zero point 0.9, point 0.9 being the most accurate. So with this model, I'm achieving close to 70%. So maybe some fine tuning is needed, but this is how the model looks when it's running in the simulation mode. I can go back to how to deploy on the device. So we would be needing VS Code for on-device deployment. So once you open VS Code, we connect the Arduino through the SSH. So this is how we do it.
So also, by the way, we are introducing VS Code as an additional step here, just to copy the files over to the Arduino board. I think the app lab in the backend has integrations with Edge Impulse. Once you have the same account on Arduino and Edge Impulse with the same email ID, your models should show up automatically in Edge Impulse in the app. There are still some things that seem to be not working there. So that's why this VS Code as a workaround to get your files in the right place.
Yep. Okay, I am connected to the Arduino. I should ideally be able to see the folder structure here of the Arduino, but uh, Rajan, do you know how I can see the folder structure?
I see you are logged into the terminal. If you go to terminal, you were logged in there. Yeah.
Yes.
Can you click on the open folder on the left? Yeah.
Oh yeah, okay. I see the file system of Arduino here. Okay, on the left. And then Arduino apps. Qualcomm keyboard. Okay. So this Qualcomm keyword is an app that I have replicated. It's basically a replica of the keyword spotting app. The
So,
example apps
so,
on
so
Arduino.
sorry, if you guys want to find out more, we covered this in part one, where you can take any sample app, you can clone it, and then you will see a clone of that app within app lab under your applications. So that's what Ramya has done, and then that's a Qualcomm keyword is a clone of the keyword spotting sample app that you saw run previously.
Yes. The example apps don't give you a way to edit any of the files in them. So that is the reason why we create replicas when we want to add our own models or make any changes to the example apps. So Qualcomm keyword is my replica of the keyword spotting example. And then, yeah. So once we have the EIM binary file that we downloaded from Edge Impulse, we come back to the app.yaml file and then add this particular line. It is supposed to be picking up the model from our PC and then putting it on the Arduino device. So this is the file I've used yesterday. I'm going to switch it up with the file I just downloaded. So this is where the thing started breaking for me. Uh, I think the integration between Edge Impulse and Arduino App Lab, that's broken somewhere. So even after switching the model out with the default model, uh, I was not able to run the app. It would result in an error, and ideally, it would not detect the keywords for me. It was still detecting the Arduino keyword. So that's where this thing failed. We are still in the process of fixing things, making sure the versions, uh, both AppLab and the Edge Impulse, are compatible with each other. But now you know how we can generate a model in Edge Impulse and how we can use it in our own apps. But yeah. Also, Rajan, if you want to switch back to the presentation, I have the QR code to the keyword spotting example on the Edge Impulse website. So,
Yes, let me go ahead and switch.
yeah. Slide slide. Can you go back?
This is the one.
No, it should be on slide 12, I guess. Give me a second. Right after the setup instructions.
I think I skipped it. My fault.
Yeah, this
This one. Yeah.
yeah. Yeah. So the workflow that I just shared, that breaks in the very last part of deploying the model on device. Uh, but that is something we are working to fix. Uh, but you could take a look at the same example, which is already listed on the Edgimpulse website. It walks through these same steps of how you collect the data, how you build a data set, how you create that impulse, um, how you configure the MFE block, how you train the neural network, and how you test the model, and then how you deploy it. So, hoping this deployment thing gets fixed with the versioning thing, but this is how the entire workflow looks like when we are building a model in a Gimpulse and deploying it on a UnoQ device.
Yeah, thank you so much, Ramya, for sharing the workflow and the sample app. Hopefully, the Edge Impulse resources and the sample apps are a good enough start for folks who are participating or even outside to start building applications with voice as a UI. Right, so a lot of these newer robotics use cases, voice as a UI has been around. Hey Alexa, hey Google. Uh, it's very intuitive for end users to now start using voice for these interfaces, and I found it personally a very good resource to understand how to train an AI model that kind of does the same, and be able to use it for my home projects as well, right? So it's been a very useful resource for me as well. So thanks, Ramya, for sharing the whole end-to-end workflow on that. Like Ramya said, we are working with both the Arduino team and Edge Impulse team to fix the little thing that's broken in the backend that's not populating the model in AppLab, but that should probably get fixed pretty soon. So I want to switch over to Q&A. I think we have a bunch of good questions come through, and let's go through them. So one of the first questions that came through was criteria for attribution of hardware. So this was around judging. So the question context was around, hey, for judging and hardware allocation, what is the criteria for it? And give me 1 second. I had it open in the background. Let me pull that up on my end. Okay. So the judging criteria basically for hardware allocation is the following. Okay. So there are project idea is one, uh, price fit category, right? So we have all of these categories: robotics, IoT, gaming, and social impact. Technical aptitude. So the judges would be kind of seeing how complex the project is, right? Whether it's just using a sample app or whether it's actually solving a very complex use case. Use of software tools, for example, App Lab is another, and then yeah, basically those are the criteria, and judges would be looking across the board, right? So project idea, price category fit, technical aptitude, and use of App Lab and other software tools. Those are the main criteria for judging for the first phase for hardware allocation. And so we'll work with Hackster and see if we can publish this as well on the website. I think that's a very fair question. We'll get them to update this. Hopefully that answered that. Let's see, what was the next one? Somebody was asking, can you share the edge impulse example? I think we did share it. I think they were asking it before we jumped into the edge impulse workflow. So again, Ramya walked us through the whole edge impulse workflow, how you can collect the data set, how you can create an impulse, train your model, and then deploy it on the end device. And then we shared the link to the keyword spotting example as well. So if you have questions, this will be published on YouTube. You can go back and check the QR codes or reach out to us on Discord. We'll be happy to share those links. The next question we got was, what interface is being used for audio capture in the UNO Q SBC? Are you using the UNO Media Carrier Shield? So Media Carrier Shield can be used, although we are not using that in this case. In this case, what Ramya's setup was the Arduino UNO Q. Actually, that's my setup as well. Is basically connected to a hub, a USB hub, and the USB hub is connected to camera and audio microphone. So in my case, it's connected to this guy. So that's our setup. It's USB hub going into peripherals, but you could use shields as well. So the next question was around multiple categories. I think I did mention it that you can qualify for multiple categories, and this is a very fair question. So the person's comment, for example, if they build around industrial IoT, say build bridges, that would be under industrial IoT, and then would that also qualify for social impact? That's exactly what it is, right? So even if you are in one of the robotics bucket or industrial IoT bucket or gaming bucket, if your project overall has social impact, that's how you could qualify for like multiple categories. And when we judge, your project would be evaluated for all the categories. So you won't be disqualified for one category just because you are doing a gaming kind of use case. Next question was, what are the prerequisites for the competition? So I don't think there are any prerequisites for the competition. Only thing for this competition is phase 1 and phase 2 is hardware allocation and then just overall project submission. So April 5th is the deadline to apply for hardware. We will be giving away, like I said, 300 4GB Arduino Uno Q devices. And then after April 5th, we will judge the initial hardware applications, distribute the hardware, and then the project submissions will go on till April 30. So even after hardware applications, if you just want to buy the Arduino Uno Q and still participate in the competition, you are more than welcome to do that. Apart from that, there is no prerequisites. We just hope that you use the Uno Q and then the software tools and do something cool. Invent some use case, solve some problem that we haven't thought about, and yeah, that's prerequisite is to come up with new ideas, I would say. Next question is, will project be developed in the limits of the scenarios described in the contest page? So the way I read this question is, if you do something completely out of the box, would you not qualify? I don't think so. I don't think it's confined to the categories that we have. Social impact, best in the contest, and then all the other 5 categories. I don't think you need to be limited to those categories that we have suggested. If you come up with completely out of the box use case, you might win the best of the contest. Who knows, right? So again, those categories are just suggestions of what we think is possible. Don't be limited by that. We don't have that much of an imagination. You guys are the imaginative folks.
Yeah, maybe we can have a whole new category of out of the box, and then
Yeah.
you could be the winner for that category.
Yeah, maybe we can include that next time. We'll work with
Yeah.
Hacker to do that. Yeah, and yeah, like I said, maybe you can win the best of the best by just doing something completely out of the left field.
Yeah.
Uh, Next question is, will there be more sessions? So we will try to have more sessions once all the hardware is distributed. We plan to have more like office hours sort of sessions where uh, we will just be online and try to answer questions. If somebody needs support, do they have any questions, or if they find something that's broken on Edge Impulse and Arduino, like we saw, things can be broken. So if somebody breaks something and brings it to us, we'll have office hours types of sessions which are more open in format. So yes, we'll have more sessions in future. So I think that was the last question I see on our end. If I'll give it a couple of more minutes. If somebody has other questions, I'll wait for 2 more minutes. But otherwise, I think it's been a lot of fun. Uh, we have one more question. How flexible is UnoQ? Can we create our own recipe, or is it limited? The UnoQ runs Debian, and essentially the bricks are basically containers. You can basically do whatever you want on the Debian, right? Yeah, you don't have to use AppLab. You can just ADB shell into the device, write your own Python code, and do whatever it is that you want. So I try to, in my opinion, it's pretty flexible. You are not limited to. Oh, the question is Yocto recipe. So can we create our own Yocto recipe, or is it limited? It comes with a Debian build. I That's a good question around the Yocto recipe. We'll have to follow up on that. I am not aware of a Yocto recipe for the QRB 2210, but I might be mistaken. But we can follow up on that question. I think let's take a note of that and follow up. Okay. One more question. I'm a final year student. What knowledge is required? I think it's an Arduino UnoQ board. So if you are exposed to Arduino at some level, basic programming, Python, Arduino sketches, a little bit of AI. Although AI, we have tools like Edge Impulse to walk you through the whole workflow, so not much is required. I think basic Python, C++ knowledge, a little bit of AI background, but you don't need that. That's not a prerequisite. I think, yeah, if you're a final year student, you should be able to on this. Uh, can participants get some support for technical related to the project in projects that they're developing? So yes, I mean we are there to support the developer community. The Arduino folks are there. The Edge Impulse folks are there. Both the teams have very strong developer support channels. Qualcomm has Discord, like we're on Discord live session right now. Post your questions on Discord, post your questions to Arduino, to Edge Impulse. We will collectively have enough support for you guys to build something awesome with these boards. And like I said, we will have in future office hours type of sessions where we'll invite the Arduino folks, we'll invite the Edge Impulse folks. If you have any questions, we can work on that. You guys will have support for sure. So the next question is, which two or three Qualcomm AI Hub models are light enough for the 4 GB local inference? That's a good question. I would say Whisper right, but a lot of the computer vision models should work. Uh, we would encourage although starting with Edge Impulse. Ramya, I don't know if you have any thoughts on AI Hub workflows on.
I haven't really tried the AI Hub models on the Enoch Rajan, but maybe that's something to add to our pipeline next for the Enoch.
Yeah. Yeah. Awesome. That was the last question. I think we took a couple of questions that we need to follow up on. We'll post those on Discord. One is the Yocto recipe, and then AI Hub workflows is another one we need more clarity on. We'll follow up with answers to those questions on the Discord channel. So look out for those. It's been a lot of fun seeing so much interest in the contest. We have 870 plus last I checked hardware applications
Yeah.
and going strong. So once again, if you haven't already applied, go apply for hardware. Make it hard for us. Let's cross 1,000 plus hardware applications. So let's give judges a hard time. So really looking forward to this. This is awesome. Can't wait to see what everybody does with these boards. And yeah, thank you so much for joining us today.
Thank you, everybody.
Thank you.